Okay, I've written out a matrix equation here. We know how to multiply rows by columns, that's going to be easy, okay? And we know how to row reduce a matrix. That's all we need to solve this. So here's the equation. And now I do something very similar to what I would do with an equation like 5x equals 9. There I would divide both sides by 5, right? Or multiply both sides by the reciprocal of 5, which I could write as 5 to the negative 1. That makes sense? Now, that would give us x equals 5 to the negative 1 times 7, right? Well, similarly, I'm going to write this. I'm going to rewrite it as C1, C2 equals this matrix to the negative 1 power times the 1, 7. Okay? And all you got to do now is calculate the negative 1 power of a matrix, which is very easy. Okay? It's called the inverse of the matrix. So I'm going to demonstrate. And even if you've got a great big matrix, it's not that hard to get the inverse. But it's very tedious, and you're probably not ever going to write it down correctly if I get a 10 by 10 matrix. Okay? But the process is as simple as it is for 2 by 2, and we can write that one out in a couple of steps. You ready? So, we do an augmented matrix. Okay? Now, over here we write what we call the identity matrix, and I'll tell you more about why that's the identity matrix. Simply because if you multiply this matrix by anything, you get the same thing. It's an identity. Multiply it by any matrix that's compatible for multiplication. You know, it's got to have columns of length 2, right? And if you have a matrix with columns of length 14, you better have 14 ones along the diagonal and a bunch of zeros in there. Yeah, don't worry about that right now, but there's this thing called the identity matrix. It's very easy to understand, and understand why it's called the identity, okay? And I'm just giving you a quick overview of a lot of stuff here. So, you know, we'll do it more formally after next week when we have a good overview. Again, as I've said, we want that overview so you don't lose the forest for the trees as we go through the course. So, assuming that you understand matrix reduction, you see that we can reduce this matrix. And I'm not going to write down the details, but I'll ask you. You understand this step? Yeah. I want a 1 here. The reduction is going to have a 1, a 0, and a 1, right? In other words, this identity matrix is going to appear over here. And what appears over here will be the inverse. And we only got a few steps. I mean, the next step is we subtract, let's keep your fingers crossed that I do this correctly. We subtract 3 times this row from this one, that'll get rid of the 3, right? So we're going to have 1, negative 3 halves, 1 half 0, and we get a 0 here, right? And again, to get that 0, we take 3 times this, negative 3 times this, and add it to this, right? Now, negative 3 times 3 halves is 9 halves, right? And add that to 1, which is 2 halves, okay? And we get 11 halves. Okay? And then we got to take negative 3 times this row and add to this and add to this, right? Well, that's easy. That's just going to give us negative 3 halves. And then negative 3 halves is 0, or negative 3 times 0 added to 1. Well, that's going to just give us 1 because negative 3 halves is 0, 0. Okay? So our inverse matrix emerges step by step over here. Well, continuing, we've got the negative 1 and the negative 3 halves. We want a 0 and a 1 here. To get a 1 here, we have to multiply by 2 11ths, right? Now, we're not going to mess with the first row, so I'll continue that. But we've got to multiply the second row by 2 over 11 to get 1. And 2 over 11 times negative 3 halves, well, 2 times 3 is 6, 11 times 2 is 22. We get 6 over 22, right? And I'll write it as 6 over 22. It reduces it.
My name's Tina.
Okay, what's your last name?
Roberts.
Okay.
Okay, anyhow, then we do 2/11 of 1, which is just 2/11. And we're almost there. Now we just have to do -3/2 of this row added to this, and we're done. Now we'll have the identity over here, and we'll have our inverse matrix over here. Okay? So, what do I get? I get -1, I get 0, I get 1. I get the 6/22, but that's √3/11, right? Okay? So I'll go ahead and reduce that just to keep the fractions manageable. But, you know, the fractions can get awful if you got a big matrix. And then you get uncertainties if you try to round things off, and all kinds of terrible things happen, but that's later. I'll save the terrible stuff for later, okay? Okay, then what do we have to do? We have to take -3/2 of this row and add to this, right? And that's certainly going to get, sorry, 3/2 of this row added to this, and that will certainly give us a 0 here, right? Okay? And then 3/2 of this is 9/22, right? So back to the stupid 22, okay? So it's 9/22 added to 1/2. 1/2 is 11/22, okay? So I think we get 20/22, right? And then 3/2 of this is just 6/22, okay? Or that's not -1. When did I start putting a negative on that? Anyhow, then we haven't used it, so it's okay. We get 1/0/0/1, and we get, well, reducing 10/11, 3/11, 3/11, 2/11, right? Something ought to be negative. No, not necessarily. Something's wrong. Something's haywire. I screwed something up. Somewhere.
I can check on the calculator.
When you multiply -3/2 by 2/11,
Oh, that should be the
should have been
-1.
negative. The 6/22 should have been a negative.
Which one?
Second block up, that 6/22 should have stayed a negative after you multiplied -3/2 by 2/11.
That might do it, because that's going to affect this, which is the bad one. So we multiplied, oh, that was a -3/2, and we multiplied that by 2/11, right? And I lost my negative sign. So that would make that negative, and that would make this negative, so that when I add 3/2 of this to this, I'll have a -9/22, right? And then added to 11/22, it gives me 2/22? Yeah, that should be right. So, and that's 1/11. And that's right. Because there's a simple trick we can use with a 2x2 matrix. It doesn't work for anything bigger. It gets too complicated. Okay? So this matrix multiplied by this, should give us our solution, shouldn't it? Okay? If what I'm telling you is true. Okay? Well, let's see how long this video is. So let's do in another video.